So my name is Alan Gates, and I would like to talk with you for the next hour about some of the work that we're doing now in Pig, some of the things that have been added in the last release, and some future work that we would like to do. As Yasmina said, we'll be taking questions throughout the webcast, and so please feel free to type those in, and I'll stop at various points in the presentation and try to address those questions so that they don't all get stacked up at the end and we forget the context. Let me start with just a brief introduction of who I am and why I'm talking about this. I actually have been a part of the Pig project for a long time now, almost 5 years. I was part of the team that helped take it from a research project inside Yahoo to an Apache open source project and to a production level project in Yahoo that's now used there for tens of thousands of jobs a day. Something like 80% of their production jobs are done in Pig. Lots of other large companies now also use Pig, large and small companies now use Pig for their processing of data on Hadoop. I'm also the author of the book Programming Pig from O'Reilly, hence doing this webcast. And I'm involved in a number of other Apache projects as well. And I also am one of the founders of Hortonworks, which we do development and support of Hadoop and associated projects such as Pig. All right, so let's dive right into it. As I said, I want to talk quite a bit about new work that's gone into Pig recently, especially in the recent 0.10 release of Pig. And I'd like to talk some about what's next, what we feel the next steps are, but I thought I'd begin with a brief overview of what Pig is. I'm guessing some of you on the call are not already hardcore Pig users, and a little bit of introduction to what Pig is and why it's useful would be helpful. So I want to spend a few minutes on that. Pig is designed to be a data flow language for Hadoop, right? So you can use, there are things like Hive to do SQL on Hadoop, and we'll talk a little bit more about the kind of sweet spots for Hive versus Pig in a bit. And SQL has some great strengths. There's also, you can write code directly in MapReduce in Java or in some scripting language. And that's great for some types of data processing, but Pig tries to live in between those two layers, right? Pig's goal is to make processing of large sets of data relatively easy. So, and something that you don't have to write lots and lots of code for or end up rewriting the same kinds of things over and over. So let's walk through what that might look like. And I find it easiest to think about this by example. So let's assume that you own a website and you have, you're collecting logs, of course, off that website, people who come and view your pages, buy things from it, all those kinds of things. So everything that happens on that website is logged, right? And you also have registered users. And you'd like to know, of your registered users, who came to your website in the last month, right? So you just, at least, they logged in at least once, right? You want to do kind of a unique user count, basically. And then you'd like to collect that information both geographically by the zip code that they're from, and you'd also like to know demographics, and you'd like to collect that by age and gender, kind of get an idea of how your users sort themselves out in those demographic categories. So, excuse me. On the right here of the slide, we have kind of a flow chart of what that might look like, right? You're going to load data from your list of users, you're going to load your logs, you're going to do a semi-join there, by which I mean you don't have to find every time every user did a transaction, you just need to find, okay, this user did at least one transaction in these set of logs this month, so they'll pass through to the next set. Then you're going to split that data stream so that you can group it both by geographically by zip code, and that you can group it demographically by age and gender, and then you're going to store both those results. So this next slide shows you what that looks like in Pig Latin. Fairly straightforward. You're able to do that, all those data operations in, what is this, less than 20 lines of code. Think most of the verbs there, which I've tried to highlight in purple in this slide, are fairly straightforward. You see that at the top, you're loading your server logs. Then you filter out the logs so that you only get 1 month's worth of data. My example here is apparently a little old. We're loading the data for August of 2011. Then you're going to load up your user file there, load users. Then we come down to this next statement that says cogroup. You can think of cogroup as the first half of join. It doesn't actually do the join, but it collects records from 2 or more inputs together by key. So you're saying, for everything that's in the server logs with this user ID, find everything in my users file that has the same ID, and the output of this will be 1 record for each of those collections. Then we filter those records, only looking for the case where we have at least some entries in the log for this user. That's what filter grouped by not is empty does there. Then we then we spit those out. The generate flatten just takes what we have grouped up and flattens it back into 1 record per user. So now at the end of this, visited equals for each line there, you'll have 1 record for every user that came to your site at least once. And then we do the 2 separate group bys. So you'll see that we say group by zip equals group visited by zip. So you're grouping this relation called visited by the zip code, and then you skip down a few lines and see that you're again grouping visited, so it's the same to the output of that cogroup and filter statements. You're again grouping that this time by age and gender. And you run both of those outputs through count statements, and you store the results into separate files. So that's just kind of a quick example of the usage of Pig Latin here. So what are we really aiming at? We're aiming at providing all the basic data processing operators that are pretty common to use, right? So load, store, filter, project, sort, join, group, all the things that almost everybody ends up doing on their data at some point, Pig Latin includes. But we also recognize that people generally want to break out of just those operators and apply their own code. And so we make it very easy to implement user-defined functions and insert those anywhere inside your data flow. And there's somewhat of an example of that here in these count functions and isEmpty functions. Those are actually built-in user-defined functions. But you can, we'll look a little bit later at an example of how you can write your own user-defined function. So that's really what Pig Latin is after, right? Making data flow easy, giving you the basic operators so you don't have to reinvent those wheels, but then at the same time recognizing that you're going to want to insert your own logic and making that easy as well. So let's talk for just a minute about where does Pig live in the world, in the data world? People will often ask me, should I use Pig or Hive for processing my data on Hadoop? This cracks me up because I'm not quite sure that I'm supposed to give an impartial answer to that question. But I actually, my answer really is always that you should use both. They're both great tools, and they're both have different purposes, right? So one thing that a common kind of way to break up data processing is this threefold division I've put here on this slide, where you use tools to collect data, you store all that data in one place, and which in this case would be your Hadoop cluster, and then you do a lot of processing of that data in what's commonly called a data factory, right? So this is where you're cleansing the data, you're building data models out of it, you're your researchers, data scientists are probably playing with this data, trying to find deep new truths buried in there that you haven't thought of before, all these kinds of things. And this is where Pig is really, this is Pig's sweet spot. This is what it's aimed at. It does not, and it does well in an environment where this data is not yet cleansed. Pig can live with or without schemas for the data. It can handle the fact that data may have an inconsistent schema, so different records may have different fields in them. All that's fine. Pig is built to handle that. It's also built to handle inputs and outputs from different types of data storage. So your data can be an HDFS, it can be an HBase, it can be recorded in HCatalog, which is an extension of Hive's Metastore, so that Pig and Hive and others can share the data. All that's fine, right? And that kind of more wide open ecosystem is where Pig really thrives. Pig also, because it is procedural, or really data flow, not procedural, because you're telling it do this, then this, and this, it does well for building deep data pipelines, right? Something like SQL is much more declarative. In SQL, you're not telling the system how to get your data or how to process your data. You're simply telling it, this is my question, answer it. And it's up to the system to decide how best to answer that question. Pig takes a very different approach where you tell it exactly, here's this whole list of things, now do it. Now, Pig may occasionally figure out, oh, I can answer the same thing a little better by doing some optimization, just like any programming language will, do a little bit of optimization here and there to speed up your program, the execution of your program. But basically it does try to do exactly what you tell it to do. One of our mantras is pigs are domestic animals, by which we mean Pig obeys you. It does what you as the programmer tell it to do. Hive, on the other hand, lives in this data warehouse space where you're now connecting stuff to BI tools, you're doing analysis. This is where SQL shines. This is what SQL was designed for. It's what it's been being used for 20 plus years now. And so that's kind of a brief introduction to the distinction between those tools. All right, so with that, before I switch actually to the next segment, I wondered if there were any questions about Pig and where it lives and what it's trying to do that should be answered before I move on to new features.
Great. Thanks, Alan. We do have a couple questions that came in. We'll just take them in the order that they came in. A question from Annie, and you may have just answered it. She asked, I'm new to learning Pig. Can you explain the difference between Pig and Hive? Annie will just say if you need additional information, let us know on that. Ellen, was there anything more that you wanted to add about that?
I don't think so. I think I just tried to cover that, so hopefully that's good.
Great. Next one from Brad. Brad asks, does Pig cover everything like Python programming does?
No, that's an excellent question. And no, Pig is not, in technical terms, it's not what you would call a Turing-complete language, which means it doesn't have while loops, it doesn't have for loops, there's no branching with ifs, that kind of stuff. And I'm going to wander a little bit into language theory here, so forgive me, but those things like Python are what's called procedural languages, where you tell the system, do this, then do this, then do this. You are, in any of those languages, what you are specifying is control flow. You're specifying how control of the system moves from point A to point B. In Pig, you are not doing that. In Pig, you are specifying data flow. You're saying, I start out with this data set, I transform it, and it becomes this other data set, then I transform it again, and it becomes yet another data set, right? So you are able to control branching and combinations of the data, but not of the control. But it's a very legitimate question to ask, well, sometimes I need control flow, right? There are data processing algorithms that are iterative, by which I mean you have to do them over and over again. You don't know when you're going to be, you don't know when you start how many times you have to do it. An example of this is doing a page rank on the web, where you want to go out and figure out which pages on the web are more important than the others, and this boils down to being a graph processing problem. But you have to iterate over it until you see convergence on the ranking of your pages. In order to accomplish that in Pig, we tightly bind it to scripting languages like Python, so it's actually very easy to embed Pig into Python so that you can do those kind of things. So you write the control flow on the outside in Python, and then you write the actual data flow inside in Pig. And I'm not going to cover that in the webcast today, but it is covered in the book on how to do that.
Great. Thank you very much, Ellen, for that. Question from Manish. Manish asks, does Pig have in-build analytical functions?
It has some, but not all. So it has basic functions that you would expect of, even old-style SQL stuff, count, min, max, all those kinds of things. It does not yet have a lot of the more advanced ones. That's an area for, we'd love to see more contributions. It's also an area where there's a lot of interesting work to do there because a lot of those are actually hard to do in a parallel system. So Pig hides from you the fact that you're operating in parallel, but you are. Right, so implementing those can be an interesting challenge. But yeah, if anyone is interested in implementing more of those, contributions are greatly welcomed.
Great, thanks. Just a couple more here. I think another beginner here with Pig, Bob asks, is Pig part of Hadoop or separate?
It is a separate project. They are both Apache projects, Pig certainly runs on top of Hadoop, but it is managed as a separate project. It has a separate management committee and that kind of stuff.
Thanks, and we'll take this last one here from Manish. I'm not sure if I'm going to read this correctly, so forgive me if I don't do a good job, Manish. Should the user ID have some type when doing co-group?
It doesn't have to. So I'm not going to delve into Pig's type model too deeply right now, other than to say that Pig is very permissive in its type model. So if you can declare types either in a schema or you can in your script itself declare it. If you don't declare it, Pig will try to infer it based on what it sees happening in the script. If you start treating something like an integer, it will decide, he thinks this is an integer, it probably is one. If it doesn't have any idea, it will just treat it as a set of bytes and not try to interpret its content at all. So that goes back to what I was saying as Pig works. Pig is built to work in an ecosystem where not a lot is known about the data, and it tries to adapt itself in a friendly way to what it finds. That goes back to our mantra of pigs eat anything, by which we mean we'll take the data whether we know everything we want to about it or not. All right, well, those are excellent questions. Let me move on to some of the new features here in Pig 0.10. I want to stress that I am not going to get to everything, even everything I put on the slides. I'm certainly not going to get to all the features because there's just too many, and I put a link here in the slides to an excellent blog post by Daniel Dye, who is the VP of Pig for Apache and one of my coworkers here, that he recently wrote this blog post and went over all the new features in Pig 0.10. I'm not going to manage to cover all those. Even everything I put in the slides I'm not going to get to because there's just only so much time in this hour. But I wanted to put them in here so that they're there for reference. And I'll hit some of the highlights, and then I'll kind of skip over some of them too. I also wanted to note Pig 0.10 is very new. It was just released a few weeks ago. We're very happy to have it out. And one thing that I'm particularly proud about is for a long time, Pig was viewed as primarily a Yahoo project, and there was a fair amount of truth in that. And I'm very proud of the fact that this release, there was a lot of effort by a lot of different groups. Major features were added by people at Twitter, by Yahoo, by Hortonworks, and we had several great contributions from Google Summer of Code students. So I just wanted to stress that we really are taking contributions from all over the place, and we're always happy to get new people who want to come on board and help out. That's one of the great joys of open source. All right, let's dive right into it here. One of the biggest feature additions of 0.10 is the ability to write user-defined functions in Ruby. So since the very beginning, you've been able to write user-defined functions in Java. Starting with Pig 0.8, we opened that up to Python. And now with 0.10, you can write your UDFs in Ruby as well. So this is great because not everybody out there is a Java programmer. In fact, that's why many people come to Pig in the first place, is they don't want to write Java code for their MapReduce to do their processing, right? They'd like to use something that's a lot more efficient in terms of their time and in terms of lines of code. So opening up the user-defined functions to the scripting language also is very powerful. So you see here an example of someone of a simple UDF that I wrote in Ruby to do mathematical power of, raise a to the power of b method here. So in the top 3 lines here, you see the Pig Latin script I wrote, where I start out by first registering this UDF. So this is the equivalent of pound include in C or import in Java. I'm just telling Pig, here's this UDF I wrote, and notice that I have to tell it I use Ruby to do this UDF, so using JRuby, which leads to the note that I said we can do them in Ruby, but we're actually using JRuby to execute these UDFs. So any Ruby you write there has to work in JRuby. There are certain Ruby modules, I believe, that are bound to a C implementation of Ruby, and those won't work in this particular instance. But 99% I think of what you want to do with Ruby out there is doable in JRuby, so this works out well. Anyway, so you register this jar as belonging to, as being in Ruby. You give it an alias saying as RF. That's just a way to refer to it later in the Pig Latin. And then you see in the last line down here, the for each generate, I invoke the function. So I just say rf.power a comma b, where a and b are fields in that record, and that will pass control to the Ruby function on so Pig will actually take this Ruby class, wrap it up along with its own code and submit that to MapReduce, and then out on the map tasks, this Ruby code will be called in each map. So now obviously this requires that Ruby is installed on your cluster. Pig will bring along your Ruby method along with any other modules that it needs to execute that. So if your class depends on another module, Pig will figure that out and also bring that module along. But it doesn't bring Ruby itself along. That you have to have, or sorry, JRuby itself. It does not bring JRuby itself along. That you have to have installed. Excuse me. And then on the bottom half of the slide here, we see the actual Ruby script. I'm not going to go over this in detail, partly because I'm not really much of an advanced Ruby programmer, but you see you need to require Pig UDF here, which is just a set of utilities for Pig UDFs, gives you a base class to work from. You define a class which extends Pig UDF, this Pig UDF class. You can declare the output schema for your method by filling out this output schema variable here that just tells Pig, I expect to see an integer back from this, and I'm going to call that field A. That way Pig understands the output of the UDF and how to process it properly. This is not required. You can live without that. It just gives Pig an opportunity to do some better optimization there. And then you define the actual function here with this def power, and it takes the mantissa and the exponent, does some checking, and returns a result. In addition, for those of you who've done a fair amount of UDF programming, you know that Pig has, beyond the basic evalfunc UDF that I just showed in that last slide, there are also optimization opportunities for algebraic and accumulator UDFs where you can, these are optimizations that work better in certain cases. The algebraic ones use the combiner when it's possible. The accumulator is a memory-saving technique on the reducer. In Java, you can use these interfaces. So far, these are not available to Python users, but they are, when they were implemented in Ruby, the people doing the work on this made sure that Ruby UDFs could implement these. So you can implement a Pig UDF in a Pig algebraic UDF in Ruby, and there's an example here of Pig's count re-implemented as a Ruby UDF. So let me just say in summary of the UDFs that there is a slight performance penalty for using these. I mean, they are being interpreted on top of Java through JRuby, but obviously in terms of maintainability and ease of writing the code, you're making quite a few gains there. I don't have all the numbers for performance degradation of Ruby versus Java. It's not, the last time I saw them, it wasn't horrible. It's 10% or something. It's not 50% or 200% or something horrifying like that in most cases. And if you're, especially if you're just throwing together a quick process to prototype something or something like this, that's when these scripting ones can really be useful. And then if you find that they are becoming bottlenecks, you can, go back and bite the bullet and write it in more hand-optimized Java code in certain places. All right, let me switch now to another exciting addition in Pig 0.10, this one for Pig storage. Pig storage is the default load and store function in Pig Latin. So if you just say load some file, semicolon, you get Pig storage. It does tab, by default it does tab separated text values. You can set that delimiter to be comma or space or Control A, whatever you use to do your separation, but that's the default. In times past, if you're using Pig storage, you either had to not have a schema, which is totally fine. Again, Pig doesn't care if you don't know the schema. In that case, you just refer to things in your script as by position. You can say whatever's in column 0, whatever's in column 3. If you did have a schema and you wanted Pig to be aware of that schema, you wanted to be able to refer to columns by name, you wanted Pig to know the types of your data, you needed to declare it. And that's shown here in the middle of this slide in the A equals load student tab 10K as, and then you see we're declaring. There's a name field that's a car array, which is Pig's way of saying string. There's an age field, which is an integer, and there's a GPA field, which is a double. And this is the way we've done the default loads for a very long time. The load function actually has the ability in Pig to, if a schema is known, to communicate that. So for example, when you integrate Pig with a metadata system like hcatalog, hcatalog can communicate the schema to Pig so that the users don't need to declare it. And in this 0.10 release, we gave that same ability to Pig storage. So if you tell Pig storage to store with a schema, which you see done in the line after the load here, where you say store A into foo using Pig storage, and then you see there's this dash schema is passed as an argument, then when it writes out the file, beside that it will write a .pig_schema file, and that will record the contents of the data. And then the next time you load that using Pig storage will just find that and automatically read and process the schema. So you see in the second load here of the data, when it's A equals load foo, there's no need to declare the schema. The next line can simply refer to the fields by name and age. You don't need to have declared that. This was added to make it much easier to keep track of what's in your data. In simple examples like this one, where there's only 3 fields, name, age, and GPA, it's fairly easy to write that in your script. But in real life, where you have 40, 50, 100 fields in your data, writing that out in your script is a serious pain, right? So this is a very nice usability addition to Pig. All right, let's go through some other real quick additions to the UDF repertoire here for Pig. One is we made it much easier to implement UDFs, and I talked a little bit before about algebraic and accumulator UDFs, and one of the complaints that we heard pretty regularly from people is if you want to write an optimized UDF in Pig, you have a lot of code to write, right? Because you end up writing the basic UDF implementation, you end up writing an algebraic implementation, an accumulator implementation. So in this release, we made it so that when you implement the more complex implementation, such as algebraic, Pig will auto-generate the simpler parts, right? So if you implement algebraic, Pig can then auto-generate an accumulator and a basic implementation of that same UDF. If you implement just an accumulator portion, Pig can auto-generate the basic UDF. This just cuts down on the lines of code you have to write, right? It makes it that much easier to build new UDFs. We've added load and store functions for JSON data. This is a very popular way to store text data or text-based data. One important caveat here is the mapping between JSON's data types and Pig's is not one-to-one. You could make different choices there on how you map between those two data models. So Pig does not attempt to figure out the schema based on what it finds in the JSON. You have to actually tell it. And JSON storage will store the schema in a side file. So anytime you've stored something with the JSON storage function, you can automatically load it with the JSON loader. If you're loading new data with JSON loader, you'll have to tell it explicitly what your schema is. We've also added built-in UDFs to construct and make use of boolean filters. These are boolean filters are a valuable way to reduce your data sizes, especially in some types of joins. I'm not going to walk through those in the interest of time, but they are there. All right, so let's look at some of the improvements we made just to the language itself. We added boolean as a first-class type. In the past, boolean could be the result of an expression like in a where clause, but it could not. You couldn't actually have boolean data. If you had a field that was truly boolean, you had to represent it either as a string of true or false or as an integer of 0 or 1. Now we've made boolean a first-class type. We added 2 new operators that can be nested inside of for each, both cross and for each itself can now be nested, but we only allow one level of nesting. That nested for each cannot again itself have another level of nesting. Aliases can be reassigned, so you can now, where in the past, if once you assigned the result of an operation to an alias or a relation name, you couldn't switch that. Now you can reassign that. B equals A there in the middle of the slide is now a valid statement. And we added, in the past, limit could only take a scalar value. You had to know a priori how many records you wanted to limit your output by. Now you can limit that by an expression inside the script. So in this particular example, for example, this Pig Latin here will read the first 1% of records. So it goes through and counts the records and then just returns only the top 1% of those records. More language improvements. We've added, Pig Latin has a split operator that allows you to split the data stream, and it's perfectly legitimate to split it in such a way that everything goes to every branch of the split, but you can also put if clauses on the split so that only certain records go to certain branches. And I want to stress that a record doesn't have to go only to one branch. Your if clauses can be overlapping in such a way that a record can go to one or more branches. But in this release, we've added an otherwise clause to this, which catches all the records that didn't go to any branch. So if you look at this split without the otherwise, any ID with a value of 4 would have just been thrown on the ground in the past, which may be a perfectly legitimate thing to do, but sometimes you want to know, you may, for example, expect all your records to either be less than 3 or greater than 5, but maybe 4 is an error condition, but you'd like to catch those and put them somewhere, and that's what this otherwise will now do. You can catch any records that didn't go to one of the branches of the split and place them somewhere else. We've made it much easier to declare maps, tuples, and bags as constants. That was doable before via UDFs, but now you can do it directly with the syntax here. And finally, in the language improvement category, we've added globbing for register. So in the past, you had to register every jar that you wanted to include explicitly. This gets kind of old if you've got 15 jars in one directory that you want to add in every script. We found a lot of people tended to do that. They would have a company-wide set of jars that were distributed in one directory, and they ended up, every Pig Latin script they had ended up starting with 15 lines of registering the same file, or same jars rather. So this way now you can just say, register everything that's in this directory and you'll automatically pick those things up. All right, let's talk a little bit about performance improvements. This is always an exciting area. Like, everybody wants to see their stuff processed faster, of course. So one big area of performance improvement we did is we found that the way Pig does aggregation works very well when you have a large number of keys in what you're grouping over. So let's say, for example, you're grouping by user ID, and you have, you're a very successful website or company or whatever, so you have lots and lots of user IDs. The default algorithm that we used for grouping worked very well in that case. It didn't work so well in cases where you had a smaller set of IDs that you were grouping over. Obviously, a canonical example of this would be grouping by gender, where you only have two possible values. But maybe a more realistic one is, say, you're running over all the data for the month and you want to group by day. You're going to have at most 31 entries in your group. The algorithm we were using was not optimal for those kinds of grouping. So we've added a second grouping algorithm that performs much better in those small cardinality key cases. And Pig actually auto-selects which one is the best one. Now, you may ask, how does it know? It doesn't necessarily have statistics to figure it out, that is a correct answer. It doesn't. So what it does is it actually always starts with a hash-based aggregation, and as soon as it sees that too many keys, as soon as it starts to see that, wow, it's got more keys here that are going to work well for this hash-based aggregation, it switches algorithms over to the sort-based aggregation. And to preempt the questions, no, it doesn't have to reprocess the data. Once it makes that determination, it can use the processing it's already done in the hash-based aggregation, just sort the results of that hash and spit them out downstream, and it's good to go. Another optimization here is we changed it so that when you apply a limit to your Pig Latin script, it will, if possible, push that into the load itself, so it will actually quit reading data as soon as it's read enough records. In the past, it would still read every record, but then only return you the number you indicated. Now it will actually quit reading as quickly as it can. A note on this, just to be clear, to avoid kind of unmet expectations, this doesn't work if you place the limit after an order by or a group or a join or a distinct. Any operator that needs to see every record before it can make a decision, right? You don't know what the top 10 records are until you've looked at every record. So, this doesn't mean that in all cases limits will cause early read termination, but only in cases where it can. And finally, we added a new join implementation that's really focused on the case where you want to join two large data sets, two large data sets where you expect the number of matching keys to actually be very sparse. I won't go through all the details of this, but the basic idea is consider that you had a small sample of your users and you wanted to look across all your transactions for the last year. Those users are going to represent a relatively small number of all of your transactions over the last year, and so this would be a good choice in that case, right, because your matches are going to be very sparse. Finally, on the new features, this is the first release of Pig that works with Hadoop 2.0. So Hadoop 2.0, which was up until very recently was known as Hadoop 0.23, so those are the same thing if you're wondering, is a total rewrite of Hadoop that changes a lot of the architecture of Hadoop itself, makes it much more extensible, much easier to write new types of applications on top of Hadoop beyond just MapReduce. There's actually some very exciting work. This is the first version of Pig that works with that. Now, it does not work out of the box. The Pig that we released, if you just download it directly from Apache, will not run against will not run against Hadoop 2.0, but you just need to recompile it. All the bits are there. You just have to set the right system properties and run ant, and you will come out with a version of Pig that will run nicely against Hadoop 2.0. Now, I want to stress there are some great new features in Hadoop 2.0 that Pig can, in time, take advantage of. We're not doing that yet, which is a great segue to next steps, things we'd like to be doing. But before I make that segue, I've gone over a pile of new features, and I'm guessing there's some questions on those. So this would be a great chance to stop and cover some of those questions before I move on to other new features.
Great. Thanks, Alan. We do have just a couple questions that came in. So, folks, real quick, if you do have questions for Alan and what he's talking to you about today, please type them into the group chat. Send them in so he can answer them while we have him with us. We have a question from Royston. Royston asks, any plans to implement that Pig storage schema feature in H-based storage?
I don't know. So I don't see any reason you couldn't do that. It would be fairly easy to port the code from Pig storage to HBase. I haven't heard anybody yet say they want to do that, but it's something that I think would be relatively easy to use and probably would bring a lot of value for people.
Thank you. We have a question from Dexon. About sparse merge join. You mentioned that data sets must be sorted on join key?
Yes. So the way this particular join implementation works is that it expects the data to already be sorted. That's the way, so I'll go in just a little bit into how it works. Basically what it does is it goes out and builds an index of the data, because the data is sorted on the join key, it becomes much easier to build that index in an efficient way. And so because it assumes that the data is very sparse, it does a seek in between each record using that index as a way to do the seek, right? So that's just much easier to do when the data is already sorted. Pig has now 5 different join implementations, only 2 of which require the data to be sorted, this sparse merge join that I just described. And also we have just a regular merge join where it doesn't make any assumptions about the data being sparse, where if your data happens to already be sorted in order of the join key, then you can make use of that inside the join, and you can do your join in the map portion of your MapReduce task instead of needing to move to the reduce portion to do it. The other types of joins in Pig do not require that the data already be sorted in the proper order.
Thank you. And our final one here from Brad. Can I use Pig to create databases?
So I'm not 100% sure what you mean by create a database. You can certainly use it to load data into databases. A very common use case that we see is people use Pig to do their ETL processing effectively, to do all the cleansing, normalizing, pre-aggregation, all those kinds of things, and then they either load it into a data warehouse on Hadoop and use something like Hive over it, or we'll often see that they will then load it into a separate data warehousing tool, or data warehousing platform, something such as Oracle or Teradata or whatever. There's many of them. Any of those kinds of things. But I'm not sure that answered the question. So if I didn't, please feel free to restate the question, and we'll try to get back to it here on another pass, because I want to make sure I get the question. All right. Let me talk then a little bit about kind of where we're going. And one thing I want to stress is the nature of open source projects here, right? I am not in any sense in charge of Pig. I can't say where Pig is going next. I can talk about things I want to work on. I can talk about things I've heard other people saying they want to work on. But part of the nature and wonderfulness of open source is different people come to it with different goals, different needs, and we work together to make sure everybody gets their pieces in. So I'll talk a little bit about things that are interesting me and exciting me, things I know that others want to do, and hopefully that'll be a good at least kind of help stimulate your thought on where Pig might be going next. So as I said in the last slide, there's a lot of exciting features in Hadoop 2.0 that Pig could take advantage of that I'd like to start taking advantage of. Hadoop 2.0 doesn't bind you anymore to just MapReduce. It allows, as an implementation algorithm, it actually allows you to implement new execution algorithms on top of the Hadoop cluster. And there are some places Pig could take advantage of this, right? So MapReduce is a fine implementation, but it doesn't necessarily work super well with joins. It doesn't work, it's not the best idea sometimes for long pipelines of data because you're forced every time to keep going back through these map tasks that you don't need. You need the first map task or the first map phase rather, sorry. After that, once you do a reduce, you don't ever need to do another map phase because whatever you would do in that map phase, you can always push into the previous reduce, right? So rather than doing map reduce, you'd really like to do map reduce, reduce, reduce. Right, so I'm excited that Pig can start to make some of these changes and take advantage of these kinds of things in Hadoop 2.0. And there's other features in there as well that we believe would be good for us to take advantage of. Another area that I've been wanting to get to for a while, and I'm really hoping I can get to soon here, is Pig has a reasonable logical optimizer, by which I mean it chooses, it makes some choices about how it's going to implement your query, and it figures out how to rearrange some of the operators sometimes to do optimal things. But on the physical end, it's still, our physical planning and execution is still pretty simple, I guess would be a good way to put it. And I'd really like to see that beefed up and able to take advantage of some of the information that's available to it, right? It would be very nice if when you go to do a join operation, for example, Pig could look at the sizes of your data in HDFS and make a decision about what the best join implementation is. And it would be even cooler if it could, in the middle of executing Pig Latin, decide, you know what, I didn't know beforehand the best way to do this because I didn't have enough information, but now that I've processed half the data, I have a pretty good guess about what's the right way to do the next half of this script. And so that it could do on-the-fly rewrites of its execution plan and make changes. So an example of that would be, say that you have a long Pig Latin script that's 100 lines long. You have some join operation buried in the middle of that. There's no way any optimizer could make a reasonable estimate about the right join implementation to use there because there's no way it would have data to guess that, right? But by the time it reaches that point in the script, it's actually generated all the inputs to that join. So it should have the right information and statistics to then make that join choice. If you could do things like that on the fly, I think that would really make Pig much more powerful. Let me talk a little bit about things that some other people are doing. There's a lot of work going on to improve the UDF interfaces. We saw some of that in the 0.10 release with the addition of Ruby and with the ability to auto-generate simpler types of UDFs, but I know there have been a couple different proposals of ways to make the UDF interface even easier than it is, than those changes have. There are people who would like to beef up the way Pig does handling of error records. So right now, if you have a record that doesn't, that somehow causes an error, for example, say you're dividing by some value in a record and it turns out there's a 0 in that field, so you get a division by 0 error. In those cases today, Pig will just return a null value for that record, right? It tries very hard not to ever fail an entire script just on one or two records, because anytime you have a billion records in an input set, you're almost guaranteed that some of them are bad, right? So failing everything over a few bad records is an anti-pattern. But right now, the only option is just to return a null and effectively throw that record out. And people would like to add an ability to say, any bad records from this operation should go in the sort of bad file, or maybe be handled by a user provided function or something. So the user could write code that would jump in there and decide either, yeah, this is safe to ignore, or no, this is a fatal error, or just file this for later use. Right? That's something I forgot to put on here that people are looking at doing, and I can't believe I forgot it. Is they would like to move Piggy Bank out of main Pig and into GitHub. So Piggy Bank is our collection of user-defined functions provided by other users. These aren't supported as part of Pig proper, but they are kind of other functions that people have found useful and want to share. Right now that's part of Pig, which creates a fairly high bar to get it into the you have to go through posting the JIRA, review from a committer, and all that. If this could be done in GitHub, where it was much easier for people to just share without the Pig committers themselves needing to mediate that, we believe that would be very powerful. And there's a hackathon going on tomorrow to work on that. I'll talk a little bit about that in a minute, but that's something we hope to add soon. We also have 5 Google Summer of Code students this summer working on Pig, which we're very excited about. That's the most we've ever had. We've had Google Summer of Code students for several years now, but this is the most in any one. All right, let me blow through a couple of plugs here real quickly, and then I'll take a few more questions. So I wanted to tell you about a couple other resources for learning about Pig. The Hadoop Summit is coming up in June. There's still slots to register for that. Still plenty of space there. We'd love to see you there, and there will be Pig talks going on there. Daniel and Tejas from the Pig team will be talking about in more depth about some of these new features, plus there'll be other talks about how people are using Pig in their companies, so some great Pig stuff going on there, plus lots of other Hadoop stuff. Hortonworks, the company that I helped found, also offers training and certification in Apache Hadoop, which includes training in Pig itself, includes hands-on writing of Pig Latin and all those kinds of things. We also have, as I mentioned very briefly, there's a hackathon at Twitter tomorrow. It is actually already full, but there's a wait list if you want to get on there and see if maybe some of the people that had said they want to be there can't be there. That is in San Francisco, if that geographically works for you. It's a great opportunity to get in, meet some of the committers and contributors, and just learn how to get more involved in the Pig code itself. The day before the Hadoop Summit, we will be doing a Pig meetup in San Jose at the Convention Center. I believe all or most of the Pig committers will be there. We'll be doing, just be a chance for people to share what they're doing on Pig, what works for them. We love to hear what doesn't work for you too. The loving criticism is much better than, it's really one of the best forms of feedback. It's great to hear what works for people and what doesn't. So that's a great opportunity for that. There's still lots of slots in that if you want to get involved, and if again, if you're going to be in San Jose those days, if that works for you. I think that's the end of my presentation. We have about 5 minutes left for any more questions.
Great presentation, Alan. Thank you so very, very much. We do indeed have a few more questions that have come in. Question from Rick. Where do schema sidecar files meet up with hcatalog project? Any compatibility with Hive schemas?
So where do they meet up with hcat? So hcatalog does provide schemas, but it provides much more than that, right? hcatalog is a whole table abstraction layer, so you don't have to worry about where files are stored or what format they're in or anything. It makes using Pig much easier in that sense. And it also makes it much easier to share data amongst tools. So if that's what you were going to want to do, you would, instead of using Pig schemas with Pig storage, you would just use the hcat load and store functions, which come as a part of hcatalog. That way, when you store your data, not only do you get a schema, which can be used again when you reload the data, you also get interoperability with all those other tools. So, the addition of schemas to Pig storage is great if Pig is all you're using. If you want to interoperate with the other tools, you do need to move up to hcatalog.
Thank you. Another question from Rick. Any more details you can give us on JSON loader?
I suppose I'm sure there's more details. Which ones do you want? So it works with JSON. I mean, it pretty much maps. I said the mapping was not necessarily one-to-one, or that there were different ways you could map things. The way it stores things, simple types are pretty straightforward, integers and floats and strings and all that. It stores Pig maps as JSON maps, I think. No, JSON structs. It stores a bag as a Pig bag as an array, and then it stores a tuple also as a struct with tag names, with the field names as key names in the JSON. So I don't know, that's kind of at least an intro to what it does there. It really, without knowing specifically what more details you want to know, I wouldn't know which direction to go with it there.
Thank you, Alan. Just a couple more questions here. Manish asks, if I have a set of Pig programs, and if I want to run all the programs in sequence, then how to package them?
Okay, great question. How do we put them together? So there's a couple options there. One, starting with 0.9, which has been out almost a year now, Pig actually does provide macros and include statements. So pretty much put something equivalent to the C preprocessor in there. So if you had a collection of Pig Latin statements that you want, or Pig Latin scripts you wanted to run in order, you could simply write another Pig Latin script that includes each of them, and they would get run in order. You could also use Python to manage the organization of them. If you wanted a little more control flow than just do A, then B, then C, you could actually use Python to make decisions about, okay, based on how A or B went. There are also tools like Uzi that will do workflow for Hadoop. Uzi is a workflow engine. It has Pig as one of its options. So you could, if, for example, you have a Pig Latin script you want to run, and then that's going to kick off 2 other jobs, and each of those are going to kick off other jobs, that's where things like Uzi are very useful, and those can be used to coordinate your Pig as well.
Thank you very much, Alan. Just 2 more questions here. Rick, he says, also, will Python scripts using JSON pick up and distribute required modules to task nodes? I think I heard you say when you're talking about the Ruby scripts.
Yeah, and it does now. Originally it did not. In the first implementations of Python, you had to pick that up. Now it does actually figure that out itself and bring those along, yes.
And our final question from Manish, can I write all Pig scripts in shell script sequentially?
Can I write? Oh, you mean could you write a shell script that just does this Pig? Then yeah, sure. You could use bash as your coordination of a set of Pig Latin scripts. That would work if that's your preferred environment. Sure.
All right, I don't see any additional questions, so with that, we're going to say a very big thank you to you, Alan, for presenting such an outstanding webcast, for sharing all your tips and knowledge with everybody today. Folks, we thank all of you that attended today's webcast and hope you benefited from it. We would like to let you all know Alan's book is the O'Reilly Deal of the Day. That means you can visit O'Reilly.com, look on the right-hand side. It's right there. It's called Pig. You'll see it. It's at a great price for all of you today for attending the webcast. We hope you like what you heard, and that book is filled with a lot more details for you. Again, thank you, Alan. Thank you, everyone. This will conclude today's webcast. Goodbye, everybody.